Have you ever really thought about the metals that build our world? I mean, from the forks in your kitchen drawer to the massive beams holding up our cities, they all have a place in a surprisingly simple family tree. Today, we're going to map it out.
So let's start with a question. What does a massive steel skyscraper and, say, a tiny aluminum can really have in common? I mean, yeah, they're both metals, but what makes one perfect for soaring into the sky and the other perfect for holding your soda? Well, the answer is actually pretty fascinating. And that answer lies in a simple classification system. Think of it like a family tree that helps us understand every single metal we use. It all starts with one fundamental question. Okay, so the first major split in the metal family tree comes down to this. Are we looking at a single core ingredient, or are we looking at a custom-made recipe? This is the huge difference between what we call pure metals and alloys. Yeah, it's really that straightforward. On one side, you have pure metals, which are just a single element, period. On the other side, you have alloys, which are a deliberate mixture of things. Let's break that down just a little bit more. So a pure metal, think of it like flour in a kitchen. It's one fundamental ingredient right off the periodic table. We're talking about things like pure copper or pure aluminum. They have their own unique properties, just like a bag of flour. Now an alloy, that's what happens when you start following a recipe. You take that flour, your main metal, and you start mixing in other elements like sugar or eggs to create something totally new and way better, like bread. For example, steel is just an alloy of iron and carbon, and that simple little addition makes it so much stronger than iron could ever be on its own. So we've sorted metals into pure and alloy, but hold on, there's another really crucial way to divide them, and this one all comes down to a single, very important element, iron. Any metal or alloy that's built around iron is called a ferrous metal, and the name itself is a dead giveaway. It comes from ferrum, which is simply the Latin word for iron. So if iron is the star of the show, it's a ferrous metal. And this connection goes right back to the periodic table. Remember the chemical symbol for iron? It's Fe. Well, that Fe is from ferrum, and it's the root of the word ferrous. Once you see that link, you'll never forget it. It just clicks. And here's the really cool part. You don't need a lab to figure this out. The defining characteristic, the big tell for ferrous metals, is that they're almost always magnetic. So if a magnet sticks to it, you are almost certainly dealing with a ferrous metal. And that means everything else just falls into the other category, non-ferrous metals. These are simply the metals and alloys that are not based on iron. No iron, no magnetism. Simple as that. All right, so we've got our two sets of labels, pure versus alloy, and ferrous versus non-ferrous. Now let's see how they work together to describe the metals we see every single day. And this is how we can put a real name to the metals around us. Let's take a steel girder. It's a mix, so it's an alloy, and it's based on iron, so it's ferrous. Make sense? How about a copper pipe? Well, that's just a single element, so it's a pure metal, and it has no iron, which makes it non-ferrous. See? Even brass fittings, which are alloys of copper and zinc, are non-ferrous because, again, there's no iron involved. So your common ferrous metals, the ones that'll grab a magnet, are things like steel in all its forms, that super heavy-duty cast iron, and classic wrought iron. These are the real workhorses of construction and heavy industry. Now, on the non-ferrous side, you have a much wider, more diverse variety. This group includes pure metals like aluminum and copper, but also really important alloys like brass and bronze, which are just mixtures that happen to be made without any iron. Okay, this might all seem like a simple labeling exercise, but understanding this difference is absolutely critical. And why? Because it impacts everything, from the durability of a bridge to the actual weight of a rocket. So here's the crucial point. Ferrous metals, with all that iron in them, are incredibly strong, but they have an Achilles heel. They rust. Non-ferrous metals, like aluminum, are lightweight and naturally resist corrosion. This choice is everything. It's literally what allows engineers to build a bridge that lasts for a century and an airplane that can actually get off the ground. You know, for centuries, our world has been built on this fundamental choice between ferrous and non-ferrous metals. They've really defined what's possible. Which leaves us with a final thought. As we look to the future, what new alloys and what new materials will we discover to build the world of tomorrow?